In this video, we look at logical expressions. So we can combine more than one condition with certain operators. All right, suppose person qualifies for a loan if two things are true. All right, their annual income has to be at least the minimum. So we set up a minimum here. And they've had their job for a minimum number of years. So we set up a minimum number of years, like so. All right, so program then asks for that information, and we want to combine the two conditions into a single if statement. All right, so we can say something like this: if annual income is greater than or equal to minimum salary, and we want something else to be true too. So symbol for and is two ampersands together. And that's the shift 7. And uh, um, years on job is greater than or equal to minimum years. Oops, minimum years on the job. So if both those things are true, we'll say you qualify for the loan. Else, um, you do not qualify. You do not qualify for the loan. So take a look at that. Java, C, logical expressions. Java logical expressions. All right, so please enter your annual income. Let's say I graduate with a computer science degree and I get a pretty good starting salary. But I've only had it. I only just started, so I only have it. I've only had the job for 1 year. I do not qualify for the loan. Okay, so annual income, right? 70,000. Okay, that was enough. Annual income is certainly 70,000 is certainly greater than or equal to 40, but years on the job was false. So when we join two relations with uh, and, both have to be true in order for the true branch to execute. If either one of them is false, we get the false branch. Let's try that again. Let's say sort of a low-level entry job, 35,000 a year, but I've had it for 5 years. Oh, okay. Well, here now the annual income is not enough. 35,000 is not greater than or equal to 40,000, so this is false. And as a matter of fact, Java is not even going to look at the second thing. If the first thing is false, the whole thing is false, and so we're not even going to look at it. But in this case, it happened to have been true. 5 is greater than or equal to 2. All right, so this was true, but this was false. All right, so it did not qualify. And naturally, if both things are false, we have say 35,000, and we just started 6 months ago. Oops. Okay, so we had a problem there because I tried to enter a fractional number with a next int. So I had a runtime error. Let's try that again. So 35,000, and let's say I've been there for a year. Okay, so in this case, both halves of the condition were false. And so, of course, the whole thing was false. So in order for the true branch to execute, both of these conditions have to be true. So let's say my income is 70,000, and I've been there for 3 years. Finally, okay, so I qualify for the loan. So this is how we can combine different logical relations into a larger logical expression. Another way we can do this is with or. Okay, we can say, well, if either thing is true, we're going to get a true result. So for example, consider if we want to sleep in on the weekend, or if we're on vacation. So we can sleep in if it's a Saturday or a Sunday, or if we're on vacation. So if either one of those things are true, we get to sleep in. We only have to get up if they're both false. It's not a weekend and we're not on vacation. So this starts off by asking for the information. Then we're going to combine that in a single if statement. Say, well, if weekend equals yes, or vacation equals yes. All right. If either one is true, I'm going to say you can sleep in. Else you have to get up. Let's compile that. And execute it. Okay, so is it a weekend? No. Are you on vacation? Yes. You can sleep in. Is it a weekend? Yes. Are you on vacation? No. You can sleep in. All right, so it doesn't matter which one is true, which one is false, just so long as one of them is. Right, because we've combined the conditions with or. That's those two vertical bars. And naturally, if both things are true, right, we expect a true result. Only when both halves of the statement are false are we going to get a false, going to execute the false branch. We say, no, it's not a weekend. No, we're not on vacation. Okay, only in that case, then, do we have to get up. There's another operator, the not operator. Suppose we want to just filter out one specific thing and see if it's anything other than that. So I want to know if we're cleared to enter campus, if there's any symptoms at all, right, and we can't come to campus. The only acceptable answer is none. Right, so let's say what symptoms are you experiencing? And we'll say this, string symptoms equals keyboard.next. So if symptoms equals none, okay, I'm going to contradict that. Put an exclamation point out to the left of the expression, and that means if symptoms equals none is false. All right, so if symptoms equals none is false, then we'll print a message. We'll say consider getting tested. Else cleared to enter. So what symptoms are you experiencing? Let's say cough. Consider getting tested. All right, because cough, right, is not equal to symptoms. So I said by contradicting the condition, right, if equals none is false, I'm going to execute the true branch. Otherwise, you're cleared to enter. Cough. So this catches anything that I might put besides the word none. Fever. Consider getting tested. Congestion. Consider getting tested. All right. So if it's not equal to none, expression, the true branch gets executed. The only thing that's going to get us cleared to enter here is if I put none, cleared to enter. Right. So that's the not operator.